Hello, I hope everyone is doing well this week. We are going to focus on proving trigonomic identities using the sum and difference properties. Again, with any of the trigonomic identities that we're proving, we kind of want to have our sheet in front of us with the sum and difference formulas, as well as our reciprocal identities, our quotient identities, Pythagorean, and odd and even functions. So we definitely want to have these close by as we are solving these. So this is the problem that I'm working on right now. Cosine of x minus y times the sine of x minus the sine of x minus y times the cosine of x. And we are proving that that is equal to the sine of y. So the very first thing that I'm going to do is I'm going to take the cosine of x minus y and the sine of x minus y, and I am going to substitute in using my sum and difference formulas right here. So I have the cosine of x minus y is cosine x times cosine y plus sine of x and sine y. So I'm going to put that in for my cosine of x minus y. So I have cosine of x times the cosine of y plus the sine of x times the sine of y. And this entire quantity is multiplied by the sine of x because I still have this sine of x right here. Okay, so I have substituted cosine of x minus y. This is what I have substituted for that, but my sine of x stays the same. So I am going to have to distribute that sine of x in my next step. So now I am going to take sine of xy. So I'm going to keep my subtraction, and I'm going to start in parentheses right here. And I am going to substitute sine of x minus y. So this is what I'm substituting right here. So I am going to say minus sine x times cosine y minus cosine x times sine y. And this is cosine right here, cosine right there. And that is all being multiplied by cosine of x. And I know that I ran out of room there, and I apologize. Okay, and again, we have our sine of x minus y is being substituted for this right here, sine of x times cosine of y minus cosine of x times sine of y. And our cosine of x stays right there. So now what we're going to do is we're going to use the distributive property to distribute our sine of x. Okay? So I am going to have sine of x times cosine of x times cosine of y. Okay? Then I have sine of x times sine of x. So that gives us sine squared of x times sine of y. Okay, and now I am subtracting, and now I am going to deal with all of this right here. Okay, so I'm actually distributing two things right here, and that can sometimes be confusing. So I am subtracting the minus sign. So I am subtracting this minus sign right here, and I am distributing this cosine of x. So I've got to deal with both of those. So I'm going to deal with them in two separate steps, just so we can keep that clear. So I am subtracting, and right now I am distributing the cosine of x. So I have the sine of x times the cosine of y times the cosine of x. Okay, then I am subtracting the cosine of x times the cosine of x which gives me cosine squared of x times sine of y. Okay? Now, I also have to distribute my negative. Okay? So my next step is taking this whole part together. So I'm rewriting most of this. So this is sine of x times cosine of x times cosine of y plus sine squared of x times sine of y. Okay? Now I am subtracting sine x times cosine y times cosine x. Okay? Now I am taking this minus and I am distributing it with this minus. So I am going to have a plus right there. So I'm going to have plus cosine squared of x and sine y. Okay. Now if you look closely, what you will find is that here I have positive sine of x times cosine of x times cosine of y. And here I have negative sine of x times cosine of y times cosine of x. Now I realize that here I have cosine of x times cosine of y. And here I have cosine of y times cosine of x. But the order doesn't matter there. They're all being multiplied together. So think of this as the same thing as 2 times 3 times 4 and 2 times 4 times 3. Those are exactly the same. So these can actually be canceled, or you can think about that as them being simplified out. I have a positive sine x times cosine y and a negative sine x times cosine y times cosine x. And because it's multiplication, we're in good shape. Now the reason for this right here is algebra. Okay? All I did there was I distributed. So here I distributed, and that was algebra. And up here, what I did was the sum and difference identities. So when you're talking about your reason, this is the sum and difference identities. Okay? And I definitely have kind of a mess here. So let's try to clean it up. Let's clean it up a little bit. So what I'm looking at now, and I'm going to do this in red so that we can be super clear on where we are. Now I have sine squared of x times sine of y, and I am adding that to cosine squared of x times sine of y. And if you see this right here, what we have right here is I have the sine of y is being multiplied by both of those. So I'm going to erase all this because it's definitely getting messy. Okay, so I'm erasing. And hopefully at this point what you are seeing is you are seeing that we are very close to the Pythagorean identities down here. Okay, so sine squared of x times sine of y plus cosine squared of x times sine of y. Okay, so again, I'm going to do some algebra. I am going to take out a sine of y. Okay, I'm taking that out, and I'm left with sine of it squared of x plus cosine squared of x. Okay, and that's algebra. All I'm doing right there is algebra. But if I look here, sine squared of theta plus cosine squared of theta equals 1. So I can take out sine squared of x plus cosine squared of x, and I'm left with 1. So I have sine y times 1, and that is a Pythagorean identity. That's the identity that I'm using here, is the Pythagorean identity. And I have made it to my goal, which is sine of y. That was what I wanted to get to. So my final step here is just sine of y. Now, I know that got really messy and there was a lot going on. So I want to do another one. So let's look at another one. Okay, here is the next one that we are going to prove, and we are proving trigonomic identities using sum and difference properties. So I am going to try to write smaller, which will be a big feat for me, and I'm going to try to use some different colors to try to make it a little bit more clear on what I'm substituting and what's happening here. So I have the cosine of x times the sine of x plus y minus the sine of x times the cosine of x plus y equals the sine of y. It's similar to the one that we just proved, but it is different. So you want to look very, very closely at exactly what we're proving. Again, I've got my sum and difference formulas super, super close, and I have my reciprocal, my quotient, my Pythagorean, and my odd and even functions super close. And these are important because your assignment that's due on Sunday night deals with the sum and difference properties. Okay, so here we've got sine of x plus y, and we've got cosine of x plus y. So we are going to take each one of those identities and we're going to sub them back. So here is sine of x plus y, and here is cosine of x plus y. Okay, so we are going to put that in. So I am going to start out in purple, and I want to show you in red what I'm substituting in. So my cosine of x stays, and what I am substituting in for sine of x plus y is sine of x sine of x times cosine of y plus cosine of x times sine of y. Okay. Then I am subtracting sine of x, and I am substituting in cosine of x times cosine of y minus sine of x times sine of y. Okay, now just like we did in our last one, we are going to distribute this cosine of x. Now I'm going to try to do this in different colors just so we can see what was being distributed. So I have cosine of x, okay, and I am multiplying that times sine of x times cosine of y. Okay, and I am distributing again cosine of x, and that is being multiplied by cosine of x. So hopefully there you're seeing that that's going to give me a squared times my sine of y. Okay, so I have distributed my cosine of x to both of these. Now here I am going to distribute negative sine of x, and that's a little different than what we did in the first one. In the first one, kind of our cosine was on the second side, so we were distributing a negative and the identity. Here we've got minus sine of x, so I am going to distribute this one at the same time. So I have minus sine of x, and that is being multiplied times cosine of x times cosine of y. Okay, now I have negative sine of x times negative sine of x. Now hopefully you can see that that negative sine of x and negative sine of x is going to give me positive sine of x times sine of x, and we'll turn that into sine squared of x in just a second, times my sine of y. Okay, so hopefully with this one, you're able to see what's being distributed a little clearer. So let's simplify some of this. So I have cosine of x times sine of x times cosine of y. Okay, here cosine of x times cosine of x becomes cosine squared of x times sine of y. Okay, here I have minus sine of x times cosine of x times cosine of y. Okay, then I have sine squared of x times sine of y. Okay, now I didn't write down why we were doing what we were doing, so let me go back and make some notes of that. The first thing that we did was the sum and difference identities. So this step right here is sum and difference identities. Okay, our very next step is algebra. So what we did there is we distributed. And this step is also algebra because we simplified. Now, some people put those two steps together, and that's okay. I just want you to really see what's happening here. Now, if we look here, cosine x times sine x times cosine y, I also have minus sine x times cosine y. So even though they're in a little different order, remember multiplication's commutative, and I can change the order for that, or associative, so I can change the order. These cancel out, okay? And that's what we want to happen. That's the goal, is we want that to happen. So now I'm left with cosine squared of x times sine y plus sine squared of x times sine of y. Again, we distribute out our sine y. I'm left with cosine squared of x plus sine squared of x. And we know we're going to use the same property again, our Pythagorean identity. Now I have sine squared of theta plus cosine squared of theta. I can rewrite that if I need to, and that's what happens here. So I can use this as my Pythagorean identity. So my final answer here is sine y times 1, and that leaves me just with sine of y, and that's what I want. So our step here was the Pythagorean identity. Okay, so you definitely want to practice those. You definitely want to be sure that you have a strong understanding of those for your assignment that's due on Sunday night.